So this question is to sum less than k. So given an integer array is not sorted, and also integer k, return a maximum sum, and I less than j, nums I plus nums j equal to sum, where sum is less than k, and then if otherwise you'd return -1. So let's just go through the logic. So the first solution is going to be brute force. I'm going to traverse the nums array, by 2 pointer. So I and j pointer, I'm going to just keep adding and keep, comparing with the k. Is the sum is less than k? If so, I'm going to just keep updating my um, return value, and definitely has to be the maximum, right? So if if the k is 60, I try to get close to 59, right? If there's no 59, I need to get to 58. If there's no 50, I need to get to 57, something like this, right? So yeah, the closest one, but not equal to k. All right. So yeah, that's it. So let's go through the first example, and then the first solution, and I will just keep diving into the second and the third. So by default, I'm going to return the -1, and then I should traverse the nums array. So the first for loop is I pointer, the second for loop is J pointer. Alright, so before I do anything, I need to tell you I'm not going to traverse all the way from beginning again, and also I and J cannot be the same, right? So I less than J, right? So it has to be what? J has to be I plus 1, and then J all the way to the end, and I needs to give one space for J, right? So it has to be what? I plus 1 less than num start length, and then J will start with I plus 1 and all the way to the end. Alright, cool. So sum is going to be equal to nums I plus nums J, right? So what I need to do is I need to calculate the sum, compare with the k. If the sum is less than k, I will update the sum equal to result. But also I want to also make sure my sum is greater than my result. So I will constantly keep updating the closest one, the maximum, the closest one to the k, right? So again, if a k equal to 60, I'm trying to make sure I getting closest to 60. So if the originally I have is 55, and I found out, oh, I have a 58 answer, I need to get my return result to 58, not 55. So that would be the first one. Cool. So time and space, time is going to be unsquared, right? Space is constant. Constant. All right. So based on this logic, all right, let's keep diving into the next solution. I'm going to have a 2 pointer, so I equal to 0 and j equal to num start length minus 1. And then I will have the return result -1. Cool. So again, the array is not sorted. So array does sort the nums. So we already know this is the ascending order, right? So smallest to largest. All right, so I would do while I less than j, and then you can tell I'm going to just keep, you know, um, comparing. Basically, it's comparing um, the sum between nums I plus nums j. So if the sum is less than k, so I will have to keep shift my I pointer to the right, right? And then in the meanwhile, I'm going to just updating my maximum result, and then comparing with the sum. Others, while I will just decrement my j. So again, let me just dive into this. Maybe you will have a better picture. So after sorting is 1, 8, 23, 24, 33, 34, 54, 75. Cool. So I'm going to say, oh, 1 plus 75 is 1 plus 75 less than k? No. So decreasing my j to here. So 1 plus 54 is 55. 55 is less than k. True. Update my, the result to 55. I increase my I. So 54 plus a is over 60. So I'm going to decreasing my j 34 and then so on, right? So let's I don't want to keep diving into. Okay, cool. So again, this is going to be straightforward as well. So time is going to be unlog, and this is like at some point like this is always cut into what one at a time or increasing one at a time. So worst case is going to be all of them, but this is the worst case unlog. Space is constant. Cool. So yeah, if you don't want to do this, then here's another solution. So I'm going to use tree set integer set equal to new tree set, and then return result is going to be -1. So for in nums to nums traversing. All right, so tree set has a method called lower. So if I can find the value for these nums, then I will just get it. Otherwise, I'm going to just find out which one is the closest one to the nums. So let's say k equal to previous. So what is the previous between the current num? But it has to be k minus current num, right? So let's see. So for example, so array is not sorted, right? 34. So 60 minus 34 is 26. Anything inside the 26? No, right? So by default, there's no value inside the tree set. I add the nums. All right. So 34 is inside the nums, right? So let me do this. So set has 34 for now. All right, 23. So the k minus 23 is 37. So lowers is going to be what? 37, and then so lower. Actually, I have a typo. Lower 37. Yes, there's a 34, right? So if there's a 34, I'm going to just calculate the difference, and then the difference is going to be what? 23 plus 34. So it will, because 23 plus 34 is definitely less than k, is because the previous is k minus nums. Alright, so let me fix the typo first. If a prev is not equal to null, result max between result is pre plus num. You need to go through this logic by yourself, because the key point is lower, and also k minus num, and also pre plus num. This is going to be a trick that is more efficient to calculate the the closest result to the k. All right, so time. So for the set, the tree set is log n for every single time when you compare. So it's going to be height of tree. So, but this is all of n. And for the lower, it's going to be log n for sure. So the worst case for the time is all of n. Space is going to be all of n, right? So this will be a solution. All right, see you later. Bye.